channels that will begin to overlap, because 5 megahertz out, if this is 10 megahertz out, then this channel actually covers up to 2.412, but the next channel is sitting here at 2.417, and the next channel is at 2.412. And then also Wi-Fi is not as nice as what this 802.11b arch is. A lot of them have a plateau shape, and I'll show that later, that have legs that extend out that even cause interference even further out than just the 10 megahertz that you would see. But one of the things that 2.4 inherently has is, because we have 11 channels crammed into such a tight window, is that overlapping channels becomes a problem, and that's a form of interference for Wi-Fi. We'll get more into that, but just want to kind of bring it out there. What you have is that the 2.4 we just talked about, 3 non-overlapping channels is all that's possible, with 1, 6, and 11 being those channels. And then 5 gigahertz though offers us up a much better opportunity, because now we have over 24 non-overlapping channels in the network. So each one of the channels is still 20 megahertz wide, but they're 20 megahertz on center, and that makes it so that then throughout that entire band, every single one of the channels that you select does not have the overlap problem, giving you more spectrum to work with. Also, in the past, 5 gigahertz wasn't as popular because the clients weren't supporting 5 gigahertz. Now, almost every client, modern client that's out there, supports the 802.11n or a specification, and some are even now supporting the AC specification, which is the latest and greatest spec that's specific on the 5 gigahertz range. So 5 gigahertz is one area that I've seen a lot of places not taking advantage of. They complain about oversaturation in the 2.4 gigahertz, but they need to get into that 5 gigahertz and check it out, because for the most part, you're going to find that there's few networks there, and if there are, 24 networks that are surrounding you, you have a chance of selecting one that has a low RSSI or a low strength, and therefore you can co-channel with them, and you introduce that a little bit of that interference. But if it's a weak enough signal, your APs will drown that out. 5 gigahertz is an area people need to start to really be looking at, but they haven't in the past. A little bit about Wi-Fi. Everybody should know this, is Wi-Fi is extremely polite. It's the Ned Flanders, if you will, of technology. It will not interrupt itself. It will not interrupt its friends, and it will also wait to talk. So it will speak, then the AP will speak, then the client will speak, and then the AP will speak, and then the client will speak. And this allows for a very good data syncing, where the ability to communicate is, if you're using your ears instead of your mouth, you're going to be able to hear what someone's saying, and then you'll be able to process it, and that's what Wi-Fi does. Whereas with the cable, Ethernet, it's full duplex, and it allows conversation back and forth. Very similar to what you'd see as if you got a group of 12-year-old girls together, when they just all start talking, and they're having a great conversation. They understand what everybody's saying, but us dads, we know that when we get in that group, we just can't process all those various conversations, and we can respect how Wi-Fi is half duplex, because that's how we all like to speak as well. Kind of looking at this from a little bit different view is that if you have multiple clients in an environment, this is where the more clients you have, and with Wi-Fi being polite, or this half duplex, is it's going to pick each client, and it's going to go from client to client to client and speak to it. And based on what the packet has in it, it may speak to the same device multiple times in a row due to, say, the payload. A device will say, hey, I need to talk with you, and I'm going to give I need to get a time window of X, and so during that time window, the AP will be listening to the client, and the client will be passing packets to it. Once that time's up, then it will jump over to the next device that's in the queue that's asking for request to send. And it'll continue to do that. And the AP will say, okay, I got a request to send. It will send out a clear to send, and then that device will begin communicating, and nothing else can communicate to that AP. Well, when you start to introduce other APs in the environment, that can create some issues. So a proper design can eliminate some of those issues that we're going to get to. So with the types of interference, just the general types of interference that you'll find in Wi-Fi, there's three main categories. Adjacent channel, this is where I'm on channel 1, and there's another network that's on channel 2. What that would be analogous to is if I'm speaking to you right now in English, and then we're having a direct conversation, back and forth direct conversation, and someone were to come in and sit right next to us and begin speaking to someone else, but they're speaking to them in the language, say Spanish, where we may understand bits and pieces of Spanish, we may understand certain words are common between English and Spanish, where we just are familiar but not fluent with Spanish, and we're having a conversation, and every once in a while we hear something that triggers us, and we have to say, what was, we have to pause our conversation to allow the people who are speaking Spanish to speak till we can understand what they're saying, because maybe they're talking to us. We don't know if they are or not, and us being polite, we want to make sure they have an opportunity to speak to us. And so therefore, we'll pause, and we'll say, oh, yeah, they're not talking to us, and then we'll continue to talk. And then again, we'll hear something else, and it'll trigger us to do that again. So that adjacent channel creates an interference in that it forces us to have to pay attention to what they're saying. How their conversation lands on us or is perceived by us will slow us down. There's another one. This is non-Wi-Fi interference. These are all sorts of devices that you can find in the environment that are broadcasting on the 2.4 gigahertz spectrum. And when they're broadcasting on that 2.4 gigahertz spectrum, they're creating this really loud. It'd be another analogy of this is we're having our conversation again, but somebody comes in with a bullhorn and just lets it go. And so you just hear this sound over our conversation, which becomes very hard for us to communicate and may become even impossible and shut our conversation down altogether. This is what you would find with non-Wi-Fi interference and how it can affect what you're doing. It can also be an intermittent one, so every once in a while we're able to talk, but we're just able to get bits and pieces of our conversation, or our conversation has to be really slow because we're waiting for that whatever the thing is that's making the noise shut up so we can talk. And then the last type of interference is co-channel interference. And co-channel interference is bad purely because of the politeness of Wi-Fi. In that, because Wi-Fi is one of these I'll talk, you talk, I talk, you talk, is that if someone's on the same channel, it's a conversation where now the people that sat beside us, they actually do speak English. And they may be having a similar conversation that we are, and so we're always waiting. Okay, you go ahead and talk. Okay, now you're done. Okay, then I'll talk. And I talk to you, and then I stop, and then they talk to their person. And that delay that occurs has to begins to slow down our throughput and our ability to communicate. Because at any moment, I'm talking to you, but you may decide to go talk to this other group that's somebody that's sitting beside us, and therefore you've roamed over, and that AP has to acknowledge that you've roamed over and that they're accepting your connection, and then get you into the queue of communication with that AP. And that's why where co-channel interference becomes important to understand. It is good because it takes advantage of the politeness of it, and we're not delaying for no reason, and we can have an efficient conversation because we know what each other is saying and how we're saying it, and therefore we know the protocols and the etiquette of that conversation. Whereas adjacent channel, we don't understand it, we're not speaking the same language, we're being overly polite, we're getting into a protection mechanism of I got to be really careful because at any moment that person, I don't know what they're saying right now, may actually want to talk to me, and I need to be present and available for them. And that's where those two really vary. But those three types of interference are good to remember because they're the things that are going to limit your ability to develop a solid network if you're not aware of them. Getting into just a little bit more of an example of each one of them, in 2.4, the 2.4 interferers, it deals with all three of the interferer types, the co-channel interference, the adjacent channel interference, and the non-Wi-Fi interference. All three of those affect the 2.4 gigahertz. Co-channel, because we may be on the same channel, and that just happens. You go and look at the networks around in your own home or neighborhood or a dense office space, there's going to be lots of networks, and since there's only 3 non-overlapping channels, there's a really good chance that we're all going to be on that a lot of us are going to be on the same channel. Then there's adjacent channel. again in a high density, with people who don't understand or not designing or implementing their networks properly, they're going to put their networks on a channel. They'll say, oh, hey, channel 2, no one's on that. And they pick channel 2. Well, what they just did is they just screwed over everybody who's on channel 1, everyone who's on channel 3, everyone who's on channel 4, and most likely everyone who's on channel 5. And just completely hosed up the conversation that we're all trying to have, and therefore becoming a bad citizen. But the individual who set that network up may not have been aware of what they were causing. They just saw, hey, there's no one on channel 2, I'm going to jump over to channel 2. It would have been a lot better if they would have just been on channel 1 with everyone else who's on 1, or moved to 6 there. But that's the adjacent channel and how it comes about. And then the non-Wi-Fi interferers, these are things that are the headset I'm wearing right now is a 2.4 gigahertz headset. It creates a non-Wi-Fi interferer. There's other things that are in the environment. Bluetooth is another common one, and other types of devices. Then there's the 5 gigahertz. And 5 gigahertz, the nice thing about it is it only has 2 types of interference. There's the co-channel and the non-Wi-Fi. And since 5 gigahertz has so many available channels, 24 of them that we can go to, it's a good likelihood that we're going to find an open channel to jump to, and we're going to eliminate that co-channel interference. There is still non-Wi-Fi interferers. It's not as common to find a 5 gigahertz, but there are cordless phones that work in 5 gigahertz. There are different types of communication devices or different types of non-Wi-Fi devices that are in the 5 gigahertz broadcasting, but not quite as much as the 2.4. So this is yet another reason why people should be jumping over to the 5 gigahertz network. So we're just talking about a little bit of congestion, give you a visualization of what you're seeing here. You know, with this first one here, this is the worst case scenario that you could have, which is a network, this red network overlap or adjacent to your network. You're on 1 and they're on 2. Then an example of what it looks like to be on co-channel. And then when you're looking at this type, this is very common that you'll find when there's a lot of APs around and all of them either mismanaged or set up once and left, is that you'll find this once to channel 4, channel 6, and a lot of people are on there and creating all this different types of interference. This is why then you, as a designer, need to see and the ability to move over and go, yep, I've got to go to channel 11 because it's open, and I need to move there. And a lot of APs won't do that on their own. There are some that have auto channel selection, but they'll also bounce around, and if anything spikes on channel 11, they pump off, and then they're back into the congestion. So these are things that you can't just always rely on it. If you're doing a business install, you really need to be aware of what that business install is and the capabilities of the APs you're putting in for the auto channel select. It more than likely is going to be a lot better for you to do a static channel selection if you have a good channel plan in place. And key to any design or development or installation of multiple APs is to have a good channel plan. Also, if you're in a dense environment and you see that there's a lot of APs that are on all these lower channels like you would see here, it'd be good to statically set your AP on 11 so it doesn't incidentally bounce to channel 1 and get caught up in this mire that's going on. Also with interferers that are non-Wi-Fi, you just want to jump away. Just a side comment I just want to make is that this is what OFDM or common Wi-Fi patterns look like. This tabletop is square, and most applications represent this trapezoidal shape that they bring all the way down, and they don't worry about these legs because for a good signal strength between here and this leg start is about between 20 and 30 dBm difference. And with that kind of a differential, this becomes a very quiet, especially if this is sitting at 60. You know, these are going to be down, 80 or lower, and they just become background noise, if you will. A lot of them becomes a problem, but for the most part, the legs aren't as critical to the impact. So interferer avoidance, we talked about that. Just get away because you have something like this in your environment. This just happens, to be a narrowband transmitter, but without a spectrum analyzer, you'll never see this. And this is where getting into products that are specific to Wi-Fi troubleshooting are necessary. You will not see this with just a Wi-Fi application. You will not see this if you just look at what channels all your neighbors are on. You need to understand if these are in the environment. And so how do we, just real quick, here's some of the usual suspects that you suspect. Wireless cameras, microwave ovens, they're a huge interferer, radio control devices, common desktop items, Bluetooth, cordless phones, mice are all part of the potential non-Wi-Fi interferers. Some of the things that you may not think of that are in the environment, printers that speak over the line, projectors who may be working on Zigbee or Bluetooth. Some of them are even Wi-Fi, so you may be communicating with one of those. HVAC systems or fans, thermostats. Cell phones are one that a lot of people don't think about, but a lot of clients will walk, an individual will walk in and they'll bring with them 2 to 3 clients. They'll have their cell phone, a tablet, and a laptop, or they'll have their phone and a laptop, or they'll have a Bluetooth headset in their phone. These are things that they're bringing into the environment. They're just bringing with them. And the average American, they're saying it has between 3 and 5 wireless devices with them. So that is. And then there's also the mixed use areas and apartments and homes. Baby monitors, some type of wireless monitoring systems are always very critical to be aware of, as well as home automation systems, electronic blinds, photostatic window or photoelectric windows, and those types of things are things that can be controlled with it. All right. So the products that we offer is that when Metageek offers 2 sets, approaches the Wi-Fi problem from 2 levels. There's the layer 1, which is the physical layer. This is where the interferers that I just talked to start to come in. The non-Wi-Fi interferers are definitely a layer 1 piece that you need to know. The raw spectrum itself, where with Ethernet it's over a copper cable or fiber optic, glass tube. Then with Wi-Fi it's the air. The air we breathe is the medium at which the Wi-Fi interfaces with. If you can't see it, you look around, you can't see the pollution from an RF perspective without a spectrum analyzer. And to be able to see that, you need something that will show you that layer 1. And then the clients themselves start to bring in interference or impact the quality of a network. And this is where packet analysis comes in. Understanding how devices are communicating on the network. Are they behaving properly? Are they speaking fast enough? Are they supporting the data rates or the PHY types that you want your network to be? Being able to see that. Malformed, consistent retransmits, a lot of clear sends, someone who's doing a brute force attack on you, someone who's got a rogue AP who's trying to siphon packets. These are things that you're going to be able to see when you look at the layer 2 that the layer 1 may or may not be able to show you. Sometimes they can show you rogue APs, sometimes they can't, but the packets will never lie because we sniff with the packet analyzers we sniff the air, we pull the packets straight out. We don't actually have to be connected to the networks. Therefore, we're able to understand if packets are being siphoned in 2 different directions. Metageek offers up is a USB spectrum analyzer. This is a device that plugs in via USB to your laptop that will allow you to collect the RF data. And that RF data is then transmitted to our application called Channelizer, and then that's what gives you the visualizations and the ability to interface with that spectrum and understand what's going on. We range from the 900 megahertz with our 900X. We have the 2.4 gigahertz coverage. Then we have a dual band Wi-Fi, which is our DBX, which gives you the 2.4 and 5 gigahertz spectrum analyzer. We also offer, for those who want to do and locate Wi-Fi or interferers in the 2.4 gigahertz range, we do have a panel directional antenna that connects to the DBX or connects to the 2.4X and allows you to point it around like a flashlight, and you can use that to go and pinpoint exactly where an interferer is located so you can physically see or interface with that interferer, potentially remove it from the environment or understand what it is to know how you should avoid it. And that's what those are really good for helping you do. So why would you need a Wi-Fi? Well, we are now in a situation where we must design good Wi-Fi networks. We can't just throw an AP into a room, let it select a channel, and be done with it. We have to understand what's also going on around us because so many people have APs, and so many people mismanage them that we need to make sure we're good citizens for our customers or for ourselves and make sure that we've got these set up properly. And what I like the analogy of is that would you go and run a bunch of cable, pull a bunch of cable through a building, through a house, and never test the actual connection and make sure that the cable is working properly? You wouldn't, because that's very difficult to troubleshoot and to fix later if you don't right off the beginning. Well, a Wi-Fi is, or any type of US or spectrum analyzer, is your cable tester for the Wi-Fi air. And that's where you kind of get with that. And then touch base, just highlight real quick, our software lineup that we have. Channelizer, this is our flagship software product. Channelizer is what gives you the visualizations. It's this application here. So it gives you that visualization of what the spectrum looks like, as well as giving you a footprint or topology of what the Wi-Fi, surrounding Wi-Fi networks are as well. So therefore you know how to interact with them. We have our IPA product, that's this one back here with these pie chart looking pieces. This is an analysis and filtering technique that we use for filtering out packets to be able to understand what's going on in the environment. Quick, easy navigation, click, click to do that filter. And then we also offer a very popular product, which is our Insider product that's on mobile devices as well as on Windows and Macintosh natively. The tablets that we offer, the mobile devices, is only on Android. We do not support iOS, nor do we support Windows Mobile because of the lack of ability to access with the Wi-Fi information that those devices have in the wireless NIC. Mac and Windows don't like you messing with their wireless NICs, and so therefore we can't communicate to them. Just a real quick one so you can see it in a little bit bigger form factor. We have Insider Office is our primary Insider application that is the most beneficial for those who are actually doing planning, monitoring, and optimization of a Wi-Fi network. It gives you a nice, good, quality network information. If you pair it with a spectrum analyzer, you can buy a nice bundled product from Microcom that has the Insider Office plus Wi-Fi Mini together. A good solid price on that for the introduction of being able to see what are the networks and what is the spectrum. You may not be able to, you won't be able to isolate a specific interferer, but you're going to be able to see what the saturation and utilization of that spectrum is, which is going to give you a lot better opportunity. We also do some link scoring with that one where we use the spectrum plus the Wi-Fi data to understand what your link score would be to a particular network or to a particular channel. Very good. We also offer up expert tips for those who are not Wi-Fi savvy to help them understand where they should go. With the stepping up in the product line is our flagship Channelizer product. This product is what is truly going to get you in and be able to see what an interferer really is, be able to go identify that interferer, go physically find it. It's going to allow you to do recordings of a session. So if you have an intermittent or transient interferer, you're going to be able to do a recording of that session and then be able to play that back like you would a DVR. That's what this is. This all waterfall view here. You can see how this interferer skipped from one location to another. Gives a nice, good density view of the spectrum. Very intuitive. Where red, as we all know, stop, bad. Something's going on. Yellow being a good warning color, green being, hey, everything's okay. It's getting a little bit loud, but it's okay. And then blue is just the background noise that you would see. This table provides you information such as all the normal network pieces, but we also offer up utilization of a particular channel or utilization of a particular AP. We give information about network quality. From there, and you're able to see things like the noise floor to be able to do signal to noise ratios, as well as classify interference. Our Channelizer product also has a module to it that does report building. This gives you the ability to generate custom reports for either yourself for archival purposes or for your customers to give to them in a PDF format saying, hey, here's what it looked like before I came, here's what it looked like after I came, voila, here you go. Here's what my design looks like. If you're doing a design, it's a great way to walk through when you're doing your site survey, collecting data about it and building a report. So then you can go back and review that so when you do your design, you can go ahead and use that information to help you understand what you're going to do with the topology of that network, and be able to help it. Plus, it allows you to monitor it. So this tool is very good from the initial design phase through the planning, installation phase, the maintenance phase, and optimization of it. And then our next and last, this is just some additional features I already went over, kind of showing you the report builder, the playback, led by waterfall, and some of the different views. And then the last products I want to give you just a few minutes to answer questions is our IPA. This is our packet analysis. This is what's going to really help you identify who is causing you problems on your network, what could be causing you problems on your network by the type of packets. If you see a lot of retries, if you see a brute force attack, those things are going to show up in a packet capture, and the ability to go in there. And it's a great intuitive. Just click on any one of these little chunks and it's going to zoom into that, tell you what's going on, and all of the information around it stays within whatever your filters that you're building. At that point, I'm done. And if there's any questions, I can answer those now. If you're sleeping, it's time to wake up and get back to work.
All right, guys, wake up. Thank you, Stony. That was fantastic.
Yeah, thanks, Crystal.
I do have a few questions for you.
Okay.
So I'll go ahead and shoot those at you, and we'll go from there.
Okay.
Question 1, what is your best-selling product and why?
Our best-selling product is the channelizer with the WiSpy DBX. The reason that this one sells so well is that we're able to, that product gives you the ability to have insight in both the 2.4 and 5 gigahertz spectrums. It allows you to identify those interferers very specifically. The price point is always the price point's always really good, because if you go and compare that product, the feature set that we offer with that product from a spectrum analysis, from a Wi-Fi deployment assistance capability and troubleshooting, you're going to pay 2 to 3x to our next competitor for it. What you're going to find as well is that our channelizer product has an extremely intuitive interface. The visualizations that we offer you is exactly what you're needing to get your problem done. Our configurations are very straightforward. You're not having to customize your profiles because all of that stays persistent. Once you've set it up the way you like it, it's there. And there's not really a whole lot of setup anyways with it. Just if you got a few tweaks here and there, you can. Unlike some of our competitors where you're having to set threshold levels, you're having to set color saturation levels, you're going to have to set up your view, and then every time you close it, you got to bring it right back up and fix it all over again, wasting time and your ability to go through and troubleshoot. Plus, you don't have to be a Wi-Fi guru to be able to use Channelizer to be able to fix problems, whereas some of the competitors, you have to be a Wi-Fi expert to be able to do
that. All right, sounds good. Next question is, what item or product line do you feel is the most bang for your buck?
The most bang for your buck, I would still say that's that channelizer package, just because of what you're getting and who you're competing against, to get similar functionality. If you're looking for a good starter or introduction into it, say something that you were going to leave behind at a customer, maybe not the tool that you're going to use to do the design or development, but something you're going to leave behind. The Insider Office is a good leave behind application because it is simple enough for someone to utilize it to do quick views, and it allows them to have a good conversation or intelligent conversation with you if you're going to go back and help troubleshoot a network or going to go back and help them with it. So from a price standpoint and for easy introduction to Wi-Fi, that's the Insider Office package. But for those who are serious about doing this, the channelizer with DBX is the key.
Fantastic. Okay, question 3. What is the range of the WiSpy Mini?
The WiSpy Mini is a 2.4 gigahertz internal antenna analyzer. So it ranges from 2.400 all the way up to 2.4835, I believe is the top range of it.
Perfect. And last, do you have a WiSpy for 365 gigahertz?
We do not have We do not have the outside. The three that we offer is the 900 megahertz, 2.4, and 5 gigahertz. We do not have it. You can tweak ours to move just below 2.4 and just above 2.4, and same with the 5, but not far enough to reach into the 3 gigahertz range. And we don't have anything that gets down low enough to the 300 megahertz, if that's where they were leading. A lot of people want to use our Wi-Fi's to do troubleshooting of cellular, and it just doesn't reach. The 900 will reach low enough into the 800 span to pick up cellular, but the 1600 and the 1800 it won't pick up, which is the most common cellular network or frequencies.
Okay. All right. Well, that's all the questions. Thank you for hosting the webinar. It's fantastic. Thank you, everybody, for attending. I hope everybody found it very informative. If you have any additional questions, you can contact us at sales@microcomtech.com. If you'd like to view products, you can visit us at www.microcom.us. Also, the webinar will be posted on our YouTube channel for later review if anybody wanted to review it again. Stoney, any last words?
Nope. Thank you very much, and happy Wi-Fi.
All right. Thanks, everybody. Have a great day.